Okay, now we're going to do section 4.2, which we're going to do conversions um, within the metric system. So there's three different ways you can do it. Moving the decimal point, using the ratio proportion method, or using the dimensional analysis method. So I will actually show you how to use all three of these ways to convert units over to other units. But once you've learned all three methods of conversion, you should select the method you are most comfortable with. Personally, I was taught using the dimensional analysis method, and I feel that it is the easiest. It may be that that's all that's the mostly what I was taught and used, but use the method that is most comfortable for you and it'll keep you from making errors. So first I'll show you how to move the decimal point. So the key to understanding the relationship in the metric system is to remember that the decimal point must be moved 3 places when converting from one unit to the next. So here are some examples. So moving the decimal point 3 places is essential equivalent to multiplying or dividing by 1,000. So to convert 1 kilogram over to grams, you would move it over 3 places. Okay, so we'll make it 1,000. And then you have 3 other examples there to follow, but I will go in more detail in the next few slides. So moving the decimal point over. First, I want to show you something because this chart I will use on this one, the dimensional analysis, and the ratio proportion. So if you notice here, all of these are like kilogram, kiloliters, kilometers. So the one thing you want to know about this one, if it says kilo, it's always going to be 0.001. So kilo means 0.001. If it just has one unit by itself and nothing in front of it, it's going to be 1. If it has milli in front of it, it's going to be 1,000. If it says micro, MC, whether it be micrometers, microliters, micrograms, if MC is there, it's going to be 1 million. Okay. And I teach this because when we get into the dimensional analysis and the ratio proportion ways, that's very helpful to know that information. So just remember, when you're converting from a smaller to a larger unit of measure, you want to move the decimal 3 places over to the left. And the way I always remember that is they are a smaller amount of people, or the population of people are left-handed. So we're going from smaller to larger. So you're going to move it to the left. Smaller amount of people are left-handed, and you're moving it to the left. Okay, so here are some examples. You have your whole number, 4,500 milliliters, and you want to move it 3 places to the left. 1, 2, 3, 4.5. Okay, so you're going from a smaller unit to a larger unit. Okay, again here, smaller unit, micrograms to grams. So you would move it 3 places over, 1.287. Milliliters, 480. You have move it over to smaller to larger units. So it's 1, 2, 3, and you have to add this leading 0 in because it is not a whole number anymore. If you're converting from a larger to a smaller unit of measure, you're going to move it 3 places to the right. So a larger number of people are right-handed. So if you go from larger to smaller, you're going to go to the right. Again, gram is larger than micrograms. So you're going to go from larger to smaller. And you're going to move the decimal point 3 places to the right. Makes it 954. 1.5 grams, you're going from larger to smaller. So move the decimal place 3 places over, and it gives you 1,500. Same with the 0.238. Grams is a larger number to smaller unit. So you want to take the decimal point 3 places over to the right, and we'll move it 238. So just remember, when you're moving the decimal point 3 spaces to the right is the same as multiplying by 1,000, or moving the decimal 3 places to the left is the same as dividing by 1,000. Okay. So just to give you some examples, if you look at your problem set, number 1, I'm just using that. It says actually to use the ratio proportion method, but I'm just going to show it to you in the decimal form. So if you just take the 964 micrograms and you want to move it over to milligrams, okay? Micrograms is smaller unit than micrograms. So if you're going from smaller to larger, you're going to move it to the left because a smaller population of people are left-handed, so we're moving it to the left. So we take our decimal, it's a whole number, and we'll add it here, move it 1, 2, 3, and it makes it 1.964 milligrams. Number 2, again, we're going to use the moving the decimal just to kind of give you some practice here. 418 milligrams, you want to go to grams, which is larger, so you're going from smaller to larger, so you're going to move it to the left. 1, 2, 3. So you have the decimal in front of the 4, so it's 0.418. Because it is no longer a whole number there, you're going to add the 0 in front of the decimal. Number 3, if you have 651 milligrams, and you want it to micrograms, you're going from a larger number to a smaller number. So you want to move it to the right. So it would be 651. You move it over to the right, you're going to have to add 3 zeros. It'll be 651 micrograms. Okay, next to set up the ratio proportion. So you just place in the unknown and the value to be converted on one side of the equation and the conversion factor and the ratio desired unit to the given unit on the other side. So just remember that the numerators units in the numerators must match, and the units in the denominators must match. So if you want to take or change 2,300 milligrams to grams, you would have X grams, and you know you have 2,300 milligrams. So that's your known. You know you need to find X grams, and you know you want to change that 2,300 milligrams to X grams. Okay. Other side, if you have to keep your units the same. So if you have grams here, you have to have grams here. If you have milligrams here, you have to have milligrams here. So remember I told you that where you find your numbers is out of that chart I gave you. If it's one unit by itself, it's a 1. If it says M for milli, that's 1,000. That easy. Okay, so now you have your 3 parts and finding your 1. Okay, with the ratio proportion, you need to cross multiply. X times 1,000, whatever you multiply the X by goes on the bottom. Okay, always. That's the rule, number 1 rule there. 2,300 times 1 is 2,300. Okay, if you want to simplify before dividing, you can, but you do not have to. I like to do it because it makes it a little bit simpler. If you have 2 zeros on top, you have to take away 2 zeros on the bottom. Okay, 23 divided by 10 would come out to be 2.3 grams. Okay, so now we want to change. Our next question is changing your 2,300 milligrams to grams. Again, I'm sorry, I've already done that one. So if you want to change 3.2 milligrams to micrograms, you set up your ratio proportion. You know you want X micrograms, and you have 3.2 milligrams. Okay, over here, if you have micrograms here, you have to have micrograms here. If you have milligrams here, your milligrams are going to go here. So milli means 1,000. Remember, micro means 1,000,000. Okay, simplify it. If you have 3 zeros here, you could take away 3 zeros here. So then, you cross multiply. X times 1 would be 1x. 1,000 times 3.2 would be 3,200. And then so it would come out 3,200 divided by 1 would be 3,200 micrograms. Okay. If you would have moved your decimal over, all you had done is had to move it over to the right. You go 1, 2, 3, so you have to add in 2 zeros, and it made it 3,200. Using the dimensional analysis method is the method I choose to do because it is most easiest for me. That is how I was taught, and I think it's just less confusing later on. But do whichever method is the most convenient for you. I will actually, after we go through these, I will actually, when I'm doing conversions, I will do the dimensional analysis with the cross, and the others I will do the ratio proportion. But you can with the problems. But you do whichever is comfortable for you. So the given number and the unit are multiplied by the ratio of the desired unit to the given unit, which is equivalent to 1. The unit in the denominator will match the given unit, so the units will cancel each other out. And the unit remaining is the numerator, which will be the unit to which we are converting. Okay, so just remember here, if you have 1 gram is equal to 1,000 milligrams, so 1 gram over 1,000 milligrams is equal to 1. So this is how you would set up the unit side from the chart. Okay, so you want to multiplying a numerator by 1 does not change its value. Okay, the way the book does it, okay, this is the way they do it. They take and convert 486 milligrams to grams. So what they're doing is they're taking it here, multiplying X grams. Okay. What they do is they'll look in, if they have milligrams here, they have to have milligrams here. This is what they're trying to find. So what they do is they look into that chart I told you to look at earlier. If it's 1 unit, if you put a 1. If it is milli, it's 1,000. Okay. Then all you have to do is take 486, times it by 1, and you get and then divide it by 1,000, and you get 0.486 grams. Okay, I do it the same way, except for I use the cross, and I'll tell you why. When you think about what you're doing, it's easier to put it in the cross. So all I'm doing is I'm taking the 486 and I'm moving it down here, because this is what I want to convert. Okay, nothing ever goes in this corner, so you can always mark it out. X grams will go in here. Okay, whatever unit is here will go into the opposite corner. Okay, so then I'll just look in my chart and I say 1 unit is a 1. Milli means 1,000. Okay, then I just multiply across. 486 times 1 is 486. Nothing times 1,000 would be 1,000. Okay, then you multiply 486 by 1,000 and you get 0.486. Okay, so it's actually the same way they're doing it here, but I think when you have this number in between, it's confusing. Okay, but I like to set it up this way, so then I'm just multiplying across, multiplying the two numbers across, multiplying the two bottoms across, and then I divide. Okay. Again, I'm going to do mine, and then on your next slide, it has their way, because I'm going to tell you something that you can do when you're doing the cross and you have it written up here. All you have to do is just put the cross in like this. You're converting 725 milligrams. Okay, if you have milligrams here, you have to have the unit of milligrams here. Okay, up here, if you want to shorten it, just the abbreviations, you can. Okay, micrograms. All you have to do is look in your chart now and see if you have micro means 1,000,000. Milli means 1,000. If you want to simplify, you can. We have 3 zeros here. We can take away 3 zeros here. We're good. Okay, so now you're left with 1 and 1,000. So you multiply across 0.725 times 1,000. It's going to give you 725. This is nothing, remember. Times 1 is always 1. And it gives you 725 divided by 1. And you get 725 micrograms, is what you've converted this 0.725 milligrams over to 725 micrograms. Okay. Or you could have just moved to decimal, whichever is easiest for you. Again, if you look on page 85, I'm going to use number 4 as an example. Even though on page 85 it tells you for number 4 to use the ratio proportion method, I'm just going to, just because I want to show you how to do these, well, actually I'll show you both ways. So on number 4, numbers 1 through 10 on page 85 say convert the following units within the metric system by using the ratio proportion method and retain all significant figures and do not round the answers. So for your practice, until you figure out which one you like best, do want numbers 1 through 10 using the ratio proportion. Then turn around and on 11 through 20, you need to convert the following metric system by using the dimensional analysis method. Okay, until you can figure out which way you like best. But I'm actually going to use both ways. Okay, so if you look at number 4, it states that you have 0.84 milligrams. You're trying to convert it into micrograms. Okay, so if you was to do the ratio and proportion method, you know you have X micrograms, which is a ratio and proportion, and then you have your 0.84 milligrams. With the ratio and proportion, remember the units on the top must match. So if you have micrograms here, you have to have micrograms here. If you have milligrams here, you have to have milligrams here. Okay? Again, you do the same thing. You look into your chart. Micro means a million. Milli means 1,000. Then next you want to just do, simplify it if you can. 3 zeros here, take away. 3 zeros here, you can take away. So you're left with 1,000 over 1. So what you need to do here is, with the ratio and proportion, you cross multiply. X times 1 will be 1x. Remember, whatever you multiply the x by always goes on the bottom. 1,000 times 0.84 would be 840. Then 840 divided by 1 is 840 micrograms. Okay. If I was going to do the, we'll put DA for dimensional analysis, and I like to do the cross. Again, you just set your cross up, nothing goes on the bottom, and then you just move the two numbers down. 0.84 goes here. You know you're trying to find micrograms, it goes here. Okay, that's all you have to do. But you're missing one unit here. So whatever unit you start with that you're converting, milligrams, is in that corner. You always put it in the corner below. Okay. So next you just go to your chart. Micrograms is a million. Milligrams means, milli means 1,000. Again, simplify. You have 3 zeros here you take away, 3 zeros here you take away. Then you just multiply across. 0.84 times 1,000 would be 840. Nothing times 1 would be 1. 840 divided by 1 is 840 micrograms. See, I think this one's the most simplest, but you may find a ratio proportion more simple, or you may just like moving the decimal. Okay. The one thing you have to remember about moving the decimal is make sure you know if you're supposed to be moving to the right or to the left. Okay, that's the only part with moving the decimal that will confuse students sometimes. Okay. Again, here, I'll do one more. See, number 11, you have 52 milliliters equals blank liters. Okay, so I'm going to do my dimensional analysis method on this one. So all you have to do is bring down the number in the units. So if you have 52 milliliters here, you'll have to have 52 here. If you have liters, X liters here, you'll have liters here. Okay, but what units, nothing goes in this box. This box, whatever units in this corner goes to that corner. So we have milliliters. Next, you look in your chart, or if you have it memorized by now. If it says milli, it means 1,000. If it's a 1 unit by itself and it doesn't have anything in front of it, it means 1. Okay. So next you want to multiply across. 52 times 1 would be 52. Nothing times 1,000 is going to be 1,000. Um, so then you have 52 over 1,000, and if you divide that, it comes out to be 0.052 liters. Again, I'm going to do number 12, and I'm taking another example here, 2.06 grams is going to equal blank milligrams. I like the cross method. Again, this gets nothing. Leave your numbers over. Okay, then you think, oh, what goes in the third one here? If you have grams up here, grams goes down here. Okay, then you look in your chart. Milli means 1,000. Grams means 1. Okay, multiply across. 2.06 times 1,000 is going to equal 2,060 divided by 1. Oops. And it equals 2,060 milligrams. So here is the question. If a patient takes 1.5 grams of moxicillin, how many capsules should the patient take? Okay, so if you look at this label here, it comes in 250 milligrams. So what you're going to have to do is convert your 1.5 grams over to milligrams and then divide by the 250 per one capsule. Okay, so you want to take 1.5 grams and you want to convert it over to milligrams because that's the way it comes stocked in the pharmacy. And then if you have grams here, you're going to have grams here, nothing in this corner. Okay, look in your chart. Milli means 1,000. 1 unit by itself means 1. So 1.5 times 1,000 would be 1,500. Divide by 1, because 1 times nothing is 1, comes up to be 1,500 milligrams. So what you've done is you've taken this 1.5 grams and you've converted it over to 1,500 milligrams. Okay, now you want to know how many capsules the patient should take. Well, this label is telling you that each capsule in this bottle is going to be worth 250 milligrams. So what you would do is you would take your 1,500 milligrams and you would divide it by 250 milligrams. The units cancel each other out. And 1,500 divided by 250 would be 6. So for that patient to take 6 capsules, it would of 1.5 grams would be the patient would take 6 capsules, and that's equal to 1.5 grams or 1,500 milligrams with 6 capsules. So if a patient is to take, this is just telling you what I did. Take 1.5 grams of amoxicillin, how many capsules should the patient take? And what I did is I converted your 1,500 milligrams over to your 1.5 grams over to milligrams. Okay, and then what I did after that was I determined the number of capsules by taking this 1.5 grams is going to be equal to 1,500 milligrams. So what I did is I took that 1,500 milligrams is going times 1 tablet divided by 250 equals 6 capsules. This is on page 41 in your book. So this is just kind of giving you some example problem sets out of there. But if you look in your book on page 86, you have 4 questions with this label. But the following prescription has come into the pharmacy, and it tells you that it's clarithromycin, which is your Viaxin generic. Okay. 125 milligrams per 5 liters, which is the same as on the label. They want them to take 2 teaspoons twice a day with food or fluid for 7 days. So question A would be, how many milliliters will the patient take daily? So what we need to do here is we need to figure up the daily dose, or in milliliters. So you have 2 teaspoons. That's one thing I don't think you've learned yet. 1 teaspoon is equal to 5 milliliters. Okay, so if you had 2 teaspoons, it's going to equal 10 milliliters. Okay, and then so forth. The dosage for this is 2 teaspoons twice a day with food, is what their label says. So for A, you do the two teaspoons, and they have BID times 7 days is what the instructions are for the label, and we're trying to figure out how many milliliters will the patient take daily. So 2 teaspoons equals 10 milliliters. Okay, then you're going to do it twice a day, so you're timesing it by 2, and it times it, but we just want to know by the day. So 10 times 2 is 20. So your answer to A on number 41 is going to be 20 milliliters. Okay, let me go ahead and erase this and do B. Okay, question B. How many milliliters should be dispensed for the patient? So, we know again, let me put this up here. Sorry about that. Just the wrong button. But again, you got 2 teaspoons, I'm putting it up here in the corner, twice a day for 7 days. So now we're just going to take that a bit further. So we know from A that they're taking 20 milliliters a day. So next, you would want to see how many they're going to be taking, how much is going to be dispensed the whole time. So we know it's for 7 days. So we know 2 teaspoons times twice a day would be 20 milliliters. Okay, so then we just need to multiply it by the amount of days they take, which would be 7. So 20 milliliters times 7 days would give you 140 milliliters. Okay, for B. C is, how many grams will the patient take daily? So with C, you have here, we know we're going to have to do a ratio proportion. Okay, we want to know how many grams they're going to take daily. You could do your conversion at the beginning or at the end. I like to do it at the beginning. So if you take X grams, okay, and we know daily, so we know they're taking 20 milliliters daily. So X grams at 20 milliliters. Then over here is going to be what you have in stock, which is 125 milligrams per 5 milliliters. So we know we have 5 milliliters here. I'm going to put milliliters here. Okay. Next, you have 125 milligrams on top. But remember, with your ratio proportions, you have to have the units on the bottom the same and the units on the top the same. So I tell people sometimes when you do a ratio proportion, you can set it up, but then you have to convert before you start. Okay, so I always make sure I have weights together on the top, liquids together on the bottom. Then I double check the units. So bottom is both liquids, both milliliters. Top is weights, but one is gram and one is milligrams. So the thing that you would want to do is you would want to take that 125 milligrams, you want to convert it over to grams. Okay, so what I do is I'll go in a little corner, a piece of paper somewhere, and I'll be like 125 milligrams. I want to convert it over to grams because that's what they're wanting it in. Milligrams here, milligrams here. 1 unit means 1, milli means 1,000. Okay, so then you have 125 divided by 1,000, and that would be 0.125. Okay, so then you take your milligrams, and what I've done is I've taken it 125 milligrams and I've converted it over to grams so they would match the top, and it would be 0.125 grams. So now they're the same. Okay, then I want to cross multiply with x times 5, always goes on the bottom, is 5. 20 times 1.25 would be 2.5. Okay, then you take your 2.5 and divide it by 5, and you should come up with 0.5 grams. Okay. So sometimes when you're doing a problem and you can set it up like a ratio proportion, sometimes you may have to convert before you solve, and that's what they're having you do there. Okay. And D is using the following drug label that you have here. How many bottles of Biaxin will be needed to fill this prescription? Well, if you notice here, it's got a total of 100 milliliters, and from answer B, you have 140 milliliters. You're going to need 2 bottles, so the 100 milliliters won't cover the 140. So you would need to give the patient, for question D, 2 bottles of medicine. Okay. Again, here is another one, your problem set labels. This is the vancomycin hydrochloride. Okay, so this one is also on page 43, and it has 2 parts to it, A and B. So you know a patient is to receive 1,000 milligrams of vancomycin 2 times daily. Okay, so the prescription is written for 1,000 milligrams of, I'm going to abbreviate vancomycin, VAN, okay, twice a day, which is BID, okay, daily, and it's going to be diluted in IV solution. The following label shows what's in stock. Okay, so this is what's in stock. We have vancomycin. It comes in 5 grams, but they've said to give them milligrams. Okay. So what you want to do here is you want to question A, which I'm going to kind of do at the bottom here. It says how many doses are available in 1 vial. So we know 1 vial, okay, is because this is a vial, is equal to 5 grams. So that is our known. 1 vial equals 5 grams. Okay. Okay. So now another thing that you need to know is you have 1,000 milligrams. Okay. That they wanted to take. So if you took 1,000 milligrams and converted it over to grams, it would be 1 gram. So 1,000, and I'll tell you how I did that, 1,000 milligrams, and we're just converting it. You want to convert it over to grams because that's what comes in the vial, okay? And then you take milligrams here, you have milligrams here, and milli means 1,000, grams means 1. Then you have 1,000 divided by 1,000 would equal 1 gram. So this 1,000 milligram is going to be equal to 1 gram. So if you know you have 5 grams in 1 vial, all you have to do is you have to take the 5 grams divided by the 1 gram to get the total number of doses, which would be 5. Okay, so that's A. For B, you want to know how many days will 1 vial last. So to do that one, you could actually do a ratio proportion with that. So just remember up here, let me erase this off so I'll have room to write. Okay, first you know You want to find out how many days should be X days and how many in this one vial. So one vial, remember I told you had 5 doses from, oops, this is B. So 5 doses. Okay. And in one day, they have 2 doses. So they're taking it twice a day. They're taking 1 gram twice a day. So you have one day is going to equal to 2 doses. Okay. And then you can cross multiply. X times 2 always goes on the bottom. It's 2 divided by 5 times 1 would be 5. So 5 divided by 2, and it should last 2.5 days. Okay, that would be all of section 4.2. I will save another recording for section 4.3.